Chain rule is one of the main tools that you have to add to your uh, toolbox of differentiation. What does it tell us is how to differentiate. So chain rule tells us how to differentiate composition of two differentiable functions. How to differentiate composition. Well, the exact wording, I am assuming that f and g are differentiable everywhere. Well, there are versions that you can make this assumption easier, but for now, that's what we need to know. Then FOG is differentiable. And we have a formula for the derivative of the composition function. This, okay, sometimes to show how this works, you will see me that writing, instead of writing FOG, I'll write F at GX. Then the way the chain rule works is that, you see, there is an inner function and there is an outer function. Of f is the outer function. It is the function that you apply at the end. Inner function is the one that you evaluate x at that function, input x into that function, and the value of that is then you evaluate at f. So here now the derivative of FOG is find first derivative of the inner one, then you multiply it by the derivative of the outer one. And when you say outer one, just derivative of outer one, it has no meaning because you have to tell me where you're evaluating that. Well, derivative of outer one evaluated at gx. Why is this good? Because before we knew that, for example, x to the power n, the derivative of x to the power n is n x to the power n minus 1. Now I can tell you what is the derivative of a general function. Let's say u to the power n. What would be this case? Okay, so here what you need to see, what you need to see is that u to the power n is basically first you find u and then find to the power n. In other words, this is f evaluated at u, and well, basically u is gx, and f is x to the power n. If you apply the chain rule to this guy, this will be the derivative of the inner one, which is u, then times the derivative of the outer one. The derivative of this guy is f prime at evaluate at u, but that is f prime is nothing but n x to the power n minus 1. And here would be n x to the power, okay, x to the power n minus 1, but you have to evaluate that u. It means that instead of x, you put u there. And well, that means that now you have more tools here. Let me write this thing. N u prime u to the power n minus 1. You apply this to sine of anything. You sine of x, we know that the derivative is cosine x. Now, if you want to find derivative of cosine of some general function, this will be cosine u, the derivative of outer one, but you have to multiply it by the derivative of inner. If you have d to the power e to the power x, the derivative before was e to the power x. Now, if you have e to the power something, the derivative would be u prime e to the power something. And this continues, like all the rules that you had before, now you can write it with the chain rule combined with that. For example, another one was the inverse function. Yes, so for example, trig inverse function, cosine inverse at x, the derivative of this guy we know is that -1 over root x squared minus 1. But now if you have derivative of cosine inverse of a function, that is going to be u prime, the whole thing you multiply it by u prime, and instead of x you put u, and so on. So if you check the table that we have in our week 5, is it week 5 or 6? I don't. 6, week 6. The table of differentiation, if you check it, you will notice that everything has two versions. One with x, the other one with u. Those u versions are basically differentiation plus chain rule. So the all differentiation you had for x plus chain rule. So that's where all these things coming from.